Okay, what do you want to write down for this first one? Bohr model of the atom. Okay, I'm all right with. Uh, okay, so Bohr's model of the atom. What is it that he added to the model of the atom? No, no. What did Bohr? He won a Nobel Prize for this. What was it that he did that he got a Nobel Prize for? No. The fact that he gave explicit orbits for the electrons. So at this point, we had already known that there was a nucleus. We knew that there were electrons. We knew that the nucleus housed all the positiveness. It was a very small, dense thing in the center of the atom. But what we didn't know is where the electrons were. So the important part of chemistry is what? Electrons, how the electrons behave. So this was the first description of where to find the electrons and why they're there. So tell me about Heisenberg. Let's start with this. What was it that Heisenberg described? Same thing here, right? They both describe the exact same thing, right? Electron locations. So why do we need a second theory on where the electrons are? Say that again?
It shows that they move around a lot, but they're not.
They show that they're closer to the nucleus.
I guess I'm asking a more generalized question. How about this? Why would anybody come up with a new theory for some scientific something or other? No, you can't prove this. Oh, improve it. Absolutely. So this was an improvement on what Bohr had done. So why, when somebody comes up with a scientific theory, and what is that all based on, for the most part? Of what, though? Like, where do they get their information to base their hypothesis on? Observed phenomenon. So they see something, and then they try to tell us why it's like that. So a lot of things in science are things that we cannot prove 100%. But I have a theory about why this does this. And if it's totally 100% absolutely right, we change the word to a law. But there's a lot of theory out there. And it's theory because we can't actually get down into the atomic level and see what the electrons are actually doing. So the first model was this Bohr model, and it was pretty good. But the problem with it is it didn't describe every interaction that we'd seen. So there were some interactions with electrons that didn't seem to make sense based off of Bohr's model. So Heisenberg comes through and says, I love your model, I think it needs improvement. And what did Bohr say? Sure, I'll help you out with that. Let's work on this together. And so we come up with the Bohr model of the atom, or that Heisenberg model of the atom, which is doing the exact same thing that Bohr did, which was describe electron locations. But his description, what can we say about it? Okay, that too, but anything else? It's better. It describes more visible things. So when I look at something, I can, at an atom on the atomic level, I can use Heisenberg's model of the atom to describe where the electrons are more often than I can use Bohr's model of the atom. So it's just an improvement. Okay, so now tell me about it. Tell me about his improvement. What did he do? Wave. Okay, so we used him and a couple other guys come up with quantum mechanics. how did they come up with this? We have calculus and statistics, and he adds those two things together. Describes electrons as a wave. The important part about this is that stops the whole elliptical orbit looking thing from Bohr's model of the atom. We have no idea how the electron gets from spot to spot. We know it moves around the nucleus, but we have zero idea how it gets there. But since we don't know how it gets there, that's why he threw the statistics in. He knows where it's gonna be. No idea how it gets there, he just knows it's going to be in this area. So this is all about guessing where it's going to be with a very, very high accuracy. As opposed to Bohr's model, which said, oh, it's going to be here, and we're going to find it in this, well, not really an elliptical orbit, but an orbit around the nucleus, and they're not always there. So when we're talking about Heisenberg's model of the atom, I just want us to think about the fact that it's math and statistics to predict where the electron is going to be, and it's improvement on the Bohr model of the atom, and we're never going to do any of the math with it. Periodic table, what's that thing based on? If it was the amount of protons, it would just be a block, right? It would just go across the page until it filled up the page, and then would start the next row. Similar chemical reactivity. Yep. So atoms in the same column are going to behave similarly chemically. What did he not base this on? Who's the guy who came up with the table in its current shape? Mendeleev. So what did he not base it on? He didn't base it on electrons because the guy didn't believe in them. But the funny thing about electrons is they're responsible for chemical reactivity. So in essence, his table is based off of electrons, even though he didn't go about doing that. Okay, so sketch a general shape of the periodic table and identify the separate blocks. All right, so let's do something like this. How about that? And then I'll go this, and I go this, and I go this, and I totally forgot another section, so I'll do this. And then we'll say S, D, P, and F. We're good with that? Can you tell me particulars about those blocks? How about just how many columns wide it is? So this one is 2, this one's 6, this one is 10, and this one is 14. What is that? How is that useful to you? Not how many orbitals. Close, you're on the right track. It's how many electrons can be housed by that sublevel. The orbitals each house 2, so if I'm looking at the S sublevel, it holds 2 electrons, and that's just 1 orbital. So how many orbitals are there in that D block? 5. Because each one of those holds 2, so a total of 10 possible electrons in a D sublevel. Okay, so the width across the periodic table is helping you determine how many electrons you're supposed to put into that orbital. Into that sublevel. So write the electron configurations for nickel, zinc, and iodine. Nitrogen. So this is atomic number 7, this is atomic number 30, and this is atomic number 53. Great, so let's go with nitrogen. So nitrogen, 1s2, 2s2, 2p, What? 3. There's only 7 electrons. I already put 4 electrons in S sublevels. I only have 3 electrons left, so I didn't fill this thing completely up. How do I know that that's correct if I'm looking at a periodic table? That this last part right here is correct, this 2p3. I go to the second row. I'd go to the P block, and I'd move over 3 columns, and what would I find there? I'd find a nitrogen. So there'd be, here's my, let's say, here's my second. So second row here. And then this is my P block here. And then the third one over, that right there will have an N in it. That'll be nitrogen. So that way I know that the last electron that I put in verified by the location on the periodic table. So it's sort of like a quick and easy check. Zinc. What are we doing with zinc? How do I start this off? 1s2, 2s2, 2p. What can I do this time? 6. What's next? How come I'm into the third energy level? There's no 2D. I've filled the first energy level and I've filled the second energy level because it only has 2 sublevels, and now I need to start filling the third energy level. So fill the third energy level. I start off with an S like I do with all of them. And so I put 2 more electrons in there. I've used 12 of my electrons. I still need to get up to 30. What comes after 3s? 3p. Then what? Okay. What comes after this 3p? 4s. We want to say 3d, but it doesn't come next. It's the 4s that comes next. So 4s, 2, and then 3d, 10. It's all the way across. It's the last atom in that first D sublevel. And so if I add all those guys up, I'm going to find that there are 30 electrons. All right, how about this iodine? What do we want to do? Well, let's go with this. So iodine, 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d10, 4. Dang it. Why is that not erasing? That's weird. 5s2, 4d10, and then 5p what? 5. So how am I like ripping through that so fast? Besides the fact I've done this for a long time. First off, they're always going to be the same. So those first 2 electrons are 1s2. Let me pick a different pen. So 2 electrons. That one's really no better. How about, this is going to be ridiculous. No, it's not. All right, so first 2 electrons are 1s2. Then that orbit or that energy level is filled. Then the next spot I fill right here. And what's that section? 2. I'm in the second column. It's 2 wide. It's the S block. So there's 2s and there's 2 electrons there. And then I hit this, and what's this? 2p6. Why isn't it 1p? There is no 1p, right? There's only a 1s. Then there's, in the second energy level, there's a 2s and a 2p. I'm filling that up. Then the next thing I hit is this 3s. Why do I have to go to the third energy level? I've already filled the second energy level. So I'm going to cruise across this 3s, and then 3p, and then 4s, and then what's this? That's 3d. And then this, 4p, 5s, 4d, 5p. And And that's how they fill. So I just fill up this section, and then if I have more electrons, then I move on to filling that. And if I have more electrons, I move on to each of these sublevels in this order. So really just use the periodic table to handle electron configurations. Energy level diagram for sulfur. So what do I need to think about with sulfur first off? What was that? It's got 16 electrons, so I'm going to need to deal with this thing's got 16 electrons. All right, so my energy level diagram, draw this, and then this is energy over here, and then this is 1s, 2s, 2p, 3s, 3p. That's all I need. So how many electrons? Can't really see that. How many electrons do I have fitting in that s? Just 2. So that's 1 orbital for all of these ones that say s. 1 orbital, and then I've got 2 different p sublevels. And what do we do with those? 3. So each of the p sublevels can hold 3 electrons. So I'll just offset them so it's easier to see. You don't need to, but whatever. Okay, so 16 electrons. I'm going to put 2 electrons here, and then 2 electrons here, and then 6 electrons here, and then 2 more electrons here. How many have I used so far? 12? Okay, so I have 4 more electrons. And this next sublevel, 3p, can hold 6, so I'm not going to completely fill it. So I'm going to put 1 electron, 1 electron, 1 electron. I got 1 left, so I double up 1. That's it. There's your energy level diagram for sulfur. It's just a visual representation with a little more information than the electron configurations give you. So why are they 1 up, 1 down? Their spins are opposite, but why does that matter? They don't want to be next to each other, so how is reversing their spin helping 2 things that don't want to be next to each other get next to each other? Because spinning electrons, which are charged, produce what? A magnetic field. So what I have is a magnetic field with reverse polarities as long as they're spinning opposite directions. So with this first one here, I've got a north pole here and a south pole here and a south pole here and a north pole here. So at least the magnets are being attracted even if the electrical fields of the 2 electrons are pushing away. And then why don't I have these guys doubled up? They'd rather be separated, but there's another orbital up here, like right above this. There's a 4s. There's a 4s sublevel right here. So when I had to double this electron up, why didn't I just throw it up there? How come that's not allowable? It requires more energy. So these orbitals are all on the same level as far as the y-axis go, meaning each of those 3 orbitals, it takes the exact same amount of energy to get into those. When we were talking about that giant building and building it in Hood River, but it doesn't have an elevator, if I'm telling you, you got to go live on the 4th floor, and then I'm putting people in each of those rooms on that 4th floor, and you didn't want to double up with somebody, you're not going to go to the 5th floor. You're not going to climb another flight of stairs just because it's available. You're going to stay on that 4th floor. So I'm not going to put this electron here into the next higher level because it takes more energy to do that. I'll just start doubling these guys up until it's full.